Hi to everybody. Today I'm going to raise you an easy question. Can you explain me why we are thrown to the front of a bus when its driver suddenly brakes? The scientific explanation has to do with three different physical quantities. First of all, velocity, then acceleration, and finally inertia. I'm going to start defining what velocity is. Velocity is the displacement per unit of time. We cannot feel any special experience which tell us if we are moving faster or slower. When we carry out an experiment inside a train, we are going to get the same outcome than when we repeat this experiment out of the train at rest, which means that we don't feel velocity. But on the contrary, we can feel a lot of unusual experiences when we are riding a bus with acceleration. Acceleration is the variation of speed per unit of time. When the driver suddenly brakes, we are pushed to the front of the bus. We can use the app FIFOX, which can be downloaded on your smartphone, to measure the effects on the acceleration in elevator in motion. First of all, the gravity acceleration is 9.8 meters per second square, but it turns to be 10.2 meters per second square when the elevator is accelerating upwards. When the elevator is moving at a constant speed, the gravity acceleration remains at 9.8 meters per second square. Finally, when it is decelerating, the gravity acceleration becomes 9.2 meters per second square. Every time we are moving at a constant speed, gravity has its usual magnitude, but when the elevator is acceleration, there is a force which is pushing on the opposite direction than acceleration. This is not because a strange force is applied to us, but it's because the third physical quantity, which is inertia. Inertia is the trend of a body which tries to keep the same state of motion unless an unbalanced force is applied to it. When the driver suddenly brakes, we try to keep moving at the same speed, which means that we are overtaking the bus. When the driver accelerates, we try to keep at rest, so we are delaying relative to the bus. That's why we feel a strange force or something which is pushing us on the opposite direction of the acceleration. We are going to check the effect of inertia with a very easy experiment. We place a glass on a table, we place a credit card on the glass and a little coin just above the card. If we apply a force to the credit card, there is no direct effect to the coin because there is no force applied directly to it. So it remains at rest. We can repeat the same experiment using a different bottle which has a really narrow at the top. We place the credit card on it and the coin. If we remove the credit card, there is no force directly applied to the coin, so it remains at rest. We can check that it doesn't move. So, to sum up, there are three physical quantities which has to do with this question. First of all, velocity, which is the displacement per unit of time. We cannot feel velocity, or we cannot state exactly whether we are at rest or moving at a constant speed. Acceleration is a change of velocity per unit of time. When we are in a frame of reference which is accelerating, we feel a strange force which is pushing us to the opposite direction. And finally, inertia, which is the trend of a body to keep at the same state of motion unless an unbalanced force is applied to it. See you soon.